Hi everyone, welcome back to IFF Academy. Today we are diving into an essential topic in calculus called differentiation. We'll cover everything from the first principles definition to key differentiation rules like addition, subtraction, product, quotient, and chain rules. By the end of this video, you'll be able to differentiate a wide variety of functions with confidence. So let's get started. Differentiation from first principles. Differentiation from first principles is the foundational definition of the derivative. It expresses the derivative as the limit of the average rate of change as the change in x approaches 0. The derivative of a function f of x is defined as f prime x is equals to limit change in x approaches 0 f of x plus change in x minus f of x over change in x. Now let's look at an example. So this is how you differentiate by first principles. So you add change in x, right? Subtract y, which is f of x, divide by change in x, right? Then take the limit, change in x approaches 0. So if you have y is equals to x raised power n, right? And we were to differentiate this. So we'll start with this. We'll start with x plus change in x raised power n minus x raised power n, right? So in this case, your f of x is what? Y. So f of x is what? Y, and it's equals to x raised power n. So we have f of, right, x plus change in x raised power n minus x raised power n, right? So this is it. Now, after over change in x, so that's how it's going to be. Now, you have to expand this. If you were to expand, x plus change in x raised power n using the binomial theorem, this is going to be x raised power n plus n x n minus 1 change in x plus blah 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 change in x raised power n. So this is the binomial expansion of x plus change in x raised power n. So if I substitute this back here, right, what do I have? I would have x raised power n plus nx n minus 1 change in x, right, plus blah 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 plus change in x raised power n minus x raised power n over change in x. Now, x raised power n would cancel out x raised power n, right? And then if you take the limit, change in x approaches 0, right? All terms with change in x except the one in the numerator vanishes as change in x approaches 0, right? So all these terms, this will vanish, this vanishes, right? And then this is approaching 0, is gone. So x raised power n minus x power n is 0. So this is the only exception. This term has change in x, so this is the only exception. The rest of the terms vanishes. So as limit x change in x approaches 0, your f prime of x will be what? N x raised power n minus 1. Right, so this is also called power rule. So now if I have y is equals to x, right? So from first principles, if I have y is equals to x from first principles, this is going to be x plus change in x minus x over change in x, right? So if you open this up, x minus x is gone. So we have change in x over change in x, right? That is your change in y over change in x is this change in y over change in x equals to. So your dy over dx will be what? 1. Because change in x over change in x is 1. So if you use that as limit, change in x approaches 0. So if you use this other formula, it's simply if you have y equals to x, that this is the same thing as y equals to x raised power 1. So it's 1 times x, 1 minus 1. Right, so we have 1 times x is power 0, and x is power 0 is 1. We have 1 times 1, which gives you 1. So now let's look at other examples. So if I have y is equals to x squared, right? Find dy over dx from first principles. So from first principles, your y prime will be what? X plus change in x minus y over change in x, right? So that's as limit change in x approaches 0. So we have y equals to x squared. So this is your y is equals to x squared, right? So this becomes x plus change in x squared minus y over change in x limit change in x approaches 0. So from here we have x plus change in x square minus y. Remember we say y is x square minus x square over change in x, right? So if you expand this, you have x square plus 2x change in x plus change in x square minus x square, right? So from here, x square and x square is out. We are left with 2x change in x plus change in x square over change in x. So change in x is common. We bring out change in x. What are we left with? 2x plus change in x, right? Because change in x times 2x gives you 2x change in x, and change in x times change in x is change in x square. So you have over change in x. So this cancels this. Right, so you're left with this 2x plus change in x. Right, so as limit change in x approaches 0, right, your dy over dx will be what? 2x. So it's as easy as that. So if you want to use this concept, y is equals to nx dy over dx is nx n minus 1, right? So if you have y is equals to x squared, your dy over dx will be what? 2x, 2 minus 1. This is 2x. So you can see it's the same thing as what we have here. So now let's look at the addition rule. The addition rule. So look at the addition rule, subtraction rule. the power rule, product rule, quotient rule. So before we go ahead and do that, let's quickly look at the standard derivatives. So here's a list of some of the standard derivatives. So on this side we have the function, on this side we have the derivative, on this side we have the function, on this side we have the derivative. So if I have x is power n, as stated earlier, the derivative will be what? Nx n minus 1. So this is what? An exponential function. This is exponential. This is logarithmic. This is trigonometric, right? This is inverse. And this is what? Hyperbolic. So you might want to pause the video and take note of these standard derivatives. All right, so now that you have written them down, let's look at the addition and subtraction rule. So for the addition rule, if y is equals to u of x plus v of x, the y over dx will be what? Du over dx plus dv over dx. So the same thing goes for subtraction, right? So if you have for subtraction rule, if you have y is equals to u of x minus v of x, dy over dx is du over dx minus dv over dx. So let's look at some examples that illustrate this. So question 1, let's say I have y is equals to 3 raised to power x plus x. So from the addition rule, what it simply says is that you find the derivative of each of the individual terms. So if I have another term here, I'll still have, let's say, w. That'll be what? dw over dx, so and so on, right? So if I have this, remember what's the derivative of 3 raised to power x? Remember we said a raised to power x is equals to a raised to power x ln a, right? So the derivative of this is what? 3 raised to power x times ln 3 plus, what's the derivative of x? That's going to be what? 1 times x raised to power 1 minus 1, right? So that gives you what? 1. So your dy over dx here is what? 3 raised to power x ln 3 plus 1. So the second question, if I have y is equals to root x plus x squared plus pi, what's the derivative going to be? So remember, this is root x is the same thing as writing x raised to power 1 over 2. So you can rewrite this as x to the power 1 over 2 plus x squared plus pi. Right, so this is going to be half x raised to power minus 1 over 2 plus 2x plus 0, because pi is a constant and the derivative of a constant is 0. So from here, your dy over dx is this. So you can simplify this further by saying this is 1 over 2 into 1 over root x plus 2x. So you have 1 over 2 root x. So question number 3, we have y is equals to exponential x plus ln x plus ln 2, right? So the derivative of exponential x is what? C exponential x. The derivative of ln x is what? 1 over x. And the derivative of ln 2 is what? 0, because ln 2 is a constant. So your dy over dx is what? 1 over x. That's easy as that. So the fourth question, if I have y equals to 2x squared minus 6x, right? So this simply becomes 4x minus 6. Now, how do we get this? This is simply 2 times 2x, 2 minus 1, right? 2 times 2 is what? 4. 2 minus 1 is what? 1. So this is the same thing as what? 4x, right? So the same thing goes here. This is 6 times 1, x, 1 minus 1, right? So 6 times 1 is what? 6. X is power 0. X power 0 is what? 1. So we have 6 times 1 gives you what? 6. So it's as easy as that. So the final one under this would be y is equals to this, we're having a hyperbolic function here. All right, so dy over dx will be what? Cos x plus 6x raised power 5. So it's as easy as that. So now let's look at the product rule. So for the product rule, if y is equals to u of x times v of x, dy over dx will be equal to u dv over dx plus v du over dx, right? So, and also, if y is equals to u of x times v of x times w of x, dy over dx will be equal to du over dx vw plus u dv over dx w plus uv dw over dx. Now let's look at some examples. So the first example we have is y is equals to 2x cos x. So you're having two functions being multiplied together. So we use what? The product rule. So this is your u of x and this is what? Your v of x. So you say u is equals to 2x. Du over dx is what? 2. V is equals to cos x. Dv over dx is what? Minus sine x. So our dy over dx is what? U is what? 2x into dv over dx is what? Minus sine x plus v is cos x into what? Du over dx, which is what? 2. So you have minus 2x sine x plus 2 cos x as your answer. So for question number 2, we have y is equals to x squared plus 2 into pi plus cos x, right? So our u is x squared plus 2. Du over dx is 2x, right? Now you know that the derivative of a constant is what? 0. So 2 is a constant. So 2 derivative of 2 is what? 0. So you have what? 2x. So and then your v is what? Pi plus cos x. Now your dv over dx will be what? Minus sine x. Now remember again, pi is a constant. So the derivative of a constant is what? 0. So your dy over dx is simply u, which is x squared plus 2 multiplied by dv over dx, which is minus sine x plus v, which is pi plus cos x multiplied by du over dx, which is what? 2x. So it's as simple as that. So now let's take the final question, the one that involves 3 products, right, being multiplied. So if I have y is equals to 5 raised to power x, okay, let's say y is equals to x squared ln x cos x, right? So this is what? U of x. This is U of x. This is V of x. And this is what? W of x. So U is equals to x squared, right? Your V is equals to what? Ln x. And W is equals to what? Cos x. So the U over dx is 2x. The V over dx is 1 over x. And the W over dx is what? Minus sine x. So all you do is what? You simply what? Substitute it into this formula. So your dy over dx becomes what? Du over dx. What's du over dx? 2x multiplied by v and w. So multiply by x square. Sorry, ln x. Multiply by ln x, right? Because that's your v. V is ln x and w is cos x. That's ln x cos x plus u is what? X square. Multiply by the v over dx is 1 over x. Multiplied by w. W is cos x. Cos x plus we have uv. What's u? X square ln x. Multiplied by the w over dx. The w over dx is minus sine x, right? So you can go ahead and simplify this further, but you can also leave it as this. So it's as simple as that. So now let's look at the quotient rule. So now we have the quotient rule. Right, so for the quotient rule, if y is equals to u of x over v of x, right, your dy over dx will be equals to v du over dx minus u dv over dx over v square. So let's look at an example. So if I have y is equals to sine x over cos x, this becomes my u, this becomes my v. So u is equals to sine x du over dx is equals to cos x, and v is equals to cos x. Dv over dx is equals to minus sine x. So my dy over dx becomes v is what? Cos x into du over dx is what? Cos x minus u is sine x, and the v over dx is what? Minus sine x over v square. That is cos square x. So I have cos square x minus sine square x over cos square x. So this gives me cos square x plus sine square x over cos square x. Now remember that sine square x plus cos square x is equals to 1, right? So it means that this place here becomes what? 1. So this is going to be equal to 1 over what? Cos square x. So your dy over dx is what? 1 over cos square x, or simply sec square x. So let's look at another example. So for example, question 2, if I have y equal to tan x over sec x, right? So this becomes my u and this becomes my v. So u is equal to tan x du over dx is equals to what? Sec square x. And v is equals to sec x. dv over dx is equals to sec x tan x from your standard derivatives. So from here, your dy over dx is simply v du over dx minus u dv over dx over v square. So what's your v? Sec x. What's your du over dx? Du over dx is sec square x minus what's u? Tan x. And what is dv over dx? Sec x tan x. And your v is sec x. So this is what your v square becomes what? Sec square x. Right. So from here, we can factor out sec x. So this becomes sec x into sec square x minus tan square x, because tan x times tan x is what? Tan square x. So you have taken this out here, and now it becomes this, and you have sec square x. So this will cancel this out, right? So you'll be left with what? Sec square x minus tan square x over sec x, right? So your dy over dx will be what? Sec square x minus tan square x over sec x. So you know that sec square x minus tan square x is 1. So you have 1 over sec x, and 1 over sec x is what? Tan x. So now let's look at the chain rule, right? So for chain rule, if I have y equals to u v of x, right? That's a function inside another function, or a composite function, or function of a function. My dy over dx is simply dy over du times du over dx, right? So if I have y is equals to ln 5x, so we're having a function 5x inside what? Ln u. So u becomes what? 5x, right? So du over dx is what? 5. And then y now becomes ln u. So the derivative of ln u will be what? That's your dy over du. That's differentiating y with respect to u gives you what? 1 over u. And then this gives you what? 1 over u is what? 5x. 1 over 5x. So your dy over dx is simply 1 over, is your dy over du, which is 1 over 5x, times du over dx is what? 5. So your dy over dx is what? 5 over 5x. That gives you what? 1 over x. Right. So the next example, if I have y is equals to cos x square, right? So u is equals to x square, du over dx is 2x, and then y becomes cos u. So if I differentiate y with respect to u here, that is dy over du becomes what? Minus sine u, right? And then this is minus sine x square. So my dy over dx is what? Dy over du, which is what? Minus sine x square into du over dx, which is what? 2x. So my dy over dx becomes minus 2x sine x square. So that's it. So let's look at one last question under this. Let's look at one last question under this. So if I have y is equals to 5 raised power x ln 3x. Now this question, we're having the chain rule and what the product rule. Now, so how do you go about this? So from here we can say our u is equals to 5 raised power x. Du over dx is what? 5 raised power x ln 5, right? So now v is equals to ln a, right? So you can say let a equals to 3x. dA over dx gives you what? 3. So since dA over dx is 3, remember we're trying to get dv over dx from here, right? We're trying to get dv over dx, but your dv over dx is going to be dA over dx times dv over dA. So from here, dv over dA is what? 1 over a. So to get dv over dx, our dv over dx is what? dA over dx, which is what? 3 times dv over dA, which is what? 1 over what? A. So this is 3 times 1 over a was what? 3x. So dv over dx is what? This cancels this. We have what? 1 over x. So we can now find the derivative from product rule, right? So from product rule, that will be u dv over dx plus v du over dx. What's our u? Our u is what? 5 raised power x. So 5 raised power x times dv over dx is what? 1 over x plus v is what? What's our v? What's our v? Ln a, which is what? Ln 3x into du over dx. Now du over dx is 5 raised power x ln 5. So that's it for this part of differentiation. So don't forget to like, subscribe, ask the questions in the comment section.